In this lecture 7, we are going to study the group theory. And as I introduced in the previous lecture, group theory is very useful theories and which describe the symmetry of molecules and the molecular orbitals. And we can obtain the various physical properties of the molecules. And in our case, as I mentioned, we want to evaluate the light absorption by group theory. This is a goal for in the next 3 lectures. And what I've shown in the previous lecture, that based on the molecular symmetry, that we can understand the transition integral is going to be 0 or not. And if it's 0, no absorption is possible. And then if S has some value, the light can be absorbed. Okay. So in the first lecture of group theory, at first very basics of the group theory to categorize the molecules by based on several symmetric operation here. So there are several symmetric operations to understand if what kind of symmetry does each molecule has. So here's the things. The first one is E. It is called identity. It's actually no operation, right? And it's at this moment it's unclear why it is necessary. So you don't do anything for a molecule, and then molecules is going to change or not. And of course, no molecules are going to change by doing nothing, right? So, but anyway, E is a first symmetric operation, do nothing. Okay, and the second operation probably it's more easy to understand, and called as Cn, which is called the n-fold axis of symmetry. And this n is an integer number, and this means that after the rotation of 360 times n degrees, the molecules are going to overlap. And you can easily understand by looking at this. So first example is which is ammonium, right? And then usually we take the axis of symmetry here and here. This is water piece, which is the principal axis. So probably natural selection of the axis for molecules, you will most likely pick up the principal axis. So in the case of ammonium, you would take the axis here. And this molecule has a C3 operation, meaning that let's see. So every 100-degree rotation around the principal axis, this molecule overlap, right? And in the case of water, that's like every 180-degree rotation, it's going to overlap around the principal axis. And this angle can be given by this one 3 means 360 over 3. but on this one, in the case of water, 360 times divided by 2, right? Meaning that this one has a C2 symmetry operation. So this is a Cn n-fold axis of symmetry. Okay. The next one is sigma V and sigma H, called reflection. In this case, sigma V is you need to think about a mirror which is parallel to the principal axis, and then after mirroring operation of molecules, the molecules are going to overlap. And in the case of sigma H, mirror is perpendicular to the principal axis. So let's see the example here. Again, the water type of the structure here, right? In this case, the principal axis is here, right? And you can think about two types of mirrors which are parallel to the principal axis. This is sigma V and sigma V dash, right? So by mirroring operation, so sigma V is kind of like vertical to the molecules, and even if the hydrogen is flipped, it's overlap. On the other hand, the sigma V dash is inside the molecular plane, and then even after mirroring operation, it's going to overlap. So they are the sigma V. And then here I don't show you the sigma H, but in the case of sigma H, the mirror must be the perpendicular to the principal axis. Okay. The next one is the I, called inversion, meaning the symmetrical center. So symmetric operation by center, it's going to overlap. Here's an example. For example, it's octahedral, and then you have a center of the object here, and then if you flip this point to this way, or flip from this way, flip from here to this way, they are going to overlap. It's called the center of inversion operation. Okay. The last one is SN, which is called a rotary reflection. It's actually a mixture of the mirror after rotation. So it's a combination of the Cn and the mirror operation, rotary reflection. Here's one of the example here. It's a bit difficult to see, but these molecules, so the principal axis is here. And you have the sigma V, or sigma H, in this case H, which is perpendicular to the molecular axis. And after rotation of 90 degree, because this one is 4, so 360 times 4, divided by 4 equal 90 degree. 90 after 90 degree rotation, and then sigma H operation. You can just imagine the structure in 90 degree rotation, and mirroring by the sigma H, it's going to overlap. And this is called rotary reflection. Okay.